The model has been exported to Tangl control. What to do next? After the model has appeared in the inbox, we can proceed to the initial analysis. First, let's create a new project in the company and name it sample. Let's create a new folder in the project. We will name the folder RST. Next, we will take a look at the tools in the Start window. The first tool is Update Data. After its activation, we get all the relevant information from the cloud. The next tool, Clear Cache, frees up the occupied space in the device's memory. Next come to the selection catalogs, which allow you to customize the validation and inspection catalogs, which will allow you to carry out complex manipulations with the selection catalogs. The next are the global settings, which establish a connection between the catalogs. And there are also settings for importing the model. They are similar to the settings that are presented in the plugin for Autodesk Revit, which we reviewed in the previous video. Also, here we have some settings to make global variables and to make some binding patterns. Next are the buttons for performing manipulations with folders within the project, which we use to create the RST folder. There are also buttons for importing models in IFC and Excel formats directly to the cloud. When importing into Excel, it is enough to indicate in which column the exported information is stored in order for the model to be loaded correctly. When we're choosing a model that we want to open, in our case we consider RST basic sample project, it becomes possible to open the 3D view with the appropriate button or by the double click. In the view, we see the geometry of the model in 3D and also the hierarchy of structures in the tree in the following order. First comes the name of the model. Inside it are the categories of elements, then type names, and then instances. For example, we have walls with the type name CLW1 and it has 9 instances inside of it. You can expand the list and see them all one by one. You can also search for elements by their name. For example, find all the elements that have standard in their name. And we can see that there are some elements. Also, when a specific element is selected, it is highlighted in blue in the model. Let's have a look at the 3D viewer tools. First, it's view mode. The first mode is the orbit mode, in which the mouse wheel controls the zoom, and when you hold down the right mouse button, the model can be rotated. Fly mode, in which when holding down the right mouse button, you can control the movement using the WASD keys and move dynamically looking for modeling flaws. The viewer also has display modes. Main mode, test mode and analysis mode. When you enable test mode, you can test bindings. Progressive render mode allows you to save data loading for convenient work. We will work with testing when checking bindings. Also, we have analysis buttons that help us to make a test analysis without saving it in the memory of the cloud service. Now let's look at the cropping tool, with which you can manually move sections and view the model inside. Pressing the crop button again turns off the tool and restores the view. If you select a specific element, you can activate cropping of a specific place, then also disable the cropping tool with a second click. If you select an element and click Zoom, you can change the focus of the screen to the element in the center. This is the main way to manipulate the view. You can also hide a specific element when an element is selected. You can go back by clicking Show All or isolate the same element. Using the example of this element, let's have a look at the tape tool. Flexible bindings can measure the distance between specific points. Control indicates the distance between the points as well as the projection on the main coordination axis. Relevant signs help you to navigate where the size is. Let's have a look at the Properties panel. All parameters from the source program get here, in our case from Autodesk Revit. It is very important that, in addition to the parameters of a particular element, the informational components of everything related to the element, for example, reference level, is shown here. The attribute tree is easy to manipulate by collapsing and expanding tabs. You can see that the type parameters fall into a separate type field. They can be expanded. Also, you can see the materials of this element by its layers. And we can see the materials not only for this particular instance, but for all the elements of this type. We can come to a conclusion that any information carries the entire content of the elements that are associated with this element. For example, we can see that material of this element is metal steel. Also, we can see the volume of this layer, its area, and other needed parameters. To test bindings, we need to activate the following window by pressing the character with curly brackets. The bindings window has condition blocks that can be used for bindings. Purple blocks are used to select the name of the parameter. In the Properties window, they are bold. The blue blocks are used to indicate the value of the parameters. Parameter values are specified after the equal sign in the Properties. Let's try to make a binding. We will bind this structural framing by the type name parameter. To do this, first we move the purple block with the name equally to the binding field. To copy the type name from the Properties window, just hold down the Alt key and left click on the parameter. After that, the name will be in the clipboard. It can be placed in the purple window. Use the right mouse button by pressing Paste or Ctrl+V. Parameter binding is ready. Now let's bind its value. To do this, we will move the blue block with the value containing and write from the keyboard B25.4. Now the element that has the type name parameter and the value of this parameter containing B25.4 must pass the binding. Let's check for this in the tree. We select the element to be tested and activate the Test Selected tool. The system will automatically switch to the test mode and highlight the element with the required color: green if it passed the binding and red if not. This element is highlighted in green, which means this element passes the test. Let's see why this is happening. To do this, we need to understand how the search works. We enter in the search type name manually. The system goes from top to the bottom until the first parameter is found. So the first parameter in this case is type name 200UB25.4. And this type of search working when the button shallow search is on. When it's off, the search will work that way that it will find all the parameters type name and everything will be alright. So if we change value to 8 millimeters and do the search with shallow search on, the element is highlighted in red. When it is off, the element is highlighted in green and it passes this binding. Also, there is an instrument regardless of the case. If we are using this instrument, it doesn't matter if we are using uppercase or lowercase letters. In test mode, you can separately control the visibility of elements that were not tested, did not pass the test, and passed the test. For example, if you turn off all but the passed ones, the corresponding parts of the model will be hidden. When pressed again, they will be shown again. So, if the testing of the bindings was successful, you can proceed to the creation of selection catalogs, which we will look at the next video.